Welcome to Review Recording 1C to accompany Instructional Recording 1C for Section 4.2, Unit 4, Chapter 4 of Mathematics 2200. We'll do some examples on solving quadratic equations by factoring. In this first one we solve for x. 3x squared equals negative 6x. It's quadratic. We always try to write our quadratic equations in this form before we try to solve by factoring. So we need to bring that negative 6x across the equal sign, make it a plus 6x. Now we factor. There is a common factor of 3x outside of x plus 2. Now that we have that, we can make each factor that contains a variable equal to 0. And in the first case, when we divide both sides by 3, we get x equals 0. That makes sense. 3 times 0 squared is 0, and negative 6 times 0 is 0. So it would balance that equation. Meanwhile, the other possibility is x equals negative 2 when we rearrange this one. So put some commas there. There we go. Now let's see. Negative 2 squared is 4 times 3 is 12. And that's supposed to equal negative 6 times negative 2. Yep, that works. 12 equals 12. So we have the correct answers, option A. Example 2 asks us to find the zeros of this function, f of x equals 2x squared minus x minus 3. Now the zeros of the function are the same as the roots of the corresponding equation. So we have 2x squared minus x minus 3 equals 0. We factor. Now, to get a 2x squared, I'm going to need to have a 2x and an x at the beginnings of my brackets. And to get a negative 3, I'll either need to have a negative 1 here and a positive 3, or positive 1, negative 3, or I can reverse the order of those places. I think the correct one that works will be negative 3 here and positive 1 there. Let's check it. That's 2x squared. We have negative 3 there, negative 3x here, and positive 2x there. We get the correct total. Good old Benny's having a good smile. So we do have the correct factoring. Now that's all equal to 0. Now that I know I have the correct factors, I make each one equal 0. So in the second case, in this first case, I'll have 2x minus 3 equals 0, 2x equals 3. Divide both sides by 2, and I've got x equals 3 over 2. My other possibility is x plus 1 equals 0, so I've got x equals negative 1. So it looks like 3 over 2 and negative 1, option D, is correct. And you can check them by substituting them back here to see if they give a value of 0 for the function. Here's a question from the June 2014 Common Final Exam. A ball is thrown from a balcony on a building and its path is represented by the function y equals negative 5x squared plus 20x plus 60. Where x is the distance in meters from the building along the ground, so it's the distance along here, and y is the height in meters above the ground. If the parking lot extends 5 meters from the building, will the ball land on the parking lot or beyond? So I've added some axes here to my diagram. The x-axis represents the distance of the ball from the building. The y-axis represents the height of the ball above the ground. The question is, if the parking lot extends 5 meters out this way, does the ball land beyond the parking lot, at the edge of the parking lot, or before the edge of the parking lot? Now, one of the keys here is to recognize that the ball lands at its height y equals 0. So really all we need to do is put 0 into this function and determine our possible values of x. So let's go ahead and do that. 0 equals negative 5x squared plus 20x plus 60. I can take out a common factor of negative 5 here. So I have negative 5 outside of x squared minus 4x minus 12. This part can be factored further. So we have 0 equals negative 5 outside of x minus 6, x plus 2. Remembering that x times x gives us x squared, negative 6 times 2 is negative 12, negative 6x and positive 2x will give us the negative 4x for the middle. Now we set each factor equals 0. So we've got x equals 6 or x equals negative 2. Now x equals negative 2 doesn't really make sense for this problem. We'd be back before the ball was even thrown. So this one gets rejected. It's inadmissible for the problem. The answer is x equals 6 meters. So the ball lands 6 meters away from the building. And since the parking lot only extends 5 meters from the building, the ball lands beyond the parking lot. To review, the zero product principle says if two numbers are multiplied to get 0, one of those numbers must be equal to 0. And we can use that to solve a quadratic equation by writing the quadratic equation in the form ax squared plus bx plus c equals 0, factoring it, applying the zero product principle by setting each factor equal to 0, and solving for the variable.